This is part 2 of the Rules of Probability video. Our 7th rule of probability is also involving conditional probability. But this is conditional probability for two independent events. What's the probability of event 1 occurring given that event 2 has already occurred? Well, if these two events have nothing to do with one another, then all you're really doing is figuring out the probability of event 1. For example, let's say that event 1 is that JT wore a hat today, and event 2 is that Malachi ate a bagel. What's the probability that JT decides to wear a hat given that Malachi decides to eat a bagel? Well, they really have nothing to do with one another, so when you're calculating two independent events, all you're doing is calculating the probability of event 1. The 9th rule of probability is the multiplication rule for independent events. The reason we're going over this first before the 8th rule is this one's a little less complicated, and I think once we understand this one, we'll be able to look at the 8th one better. If you see the word "and," that's a hint that we want to multiply two probabilities. So you're going to multiply event 1 times event 2, or however many events you happen to have. Let's say we want to find the probability of taking a coin and flipping it, it comes out tails, rolling a die and rolling a 5, and randomly choosing a card and getting the jack of spades. If we multiply those three probabilities together, that's the probability of all three events occurring, which comes out to only 0.0016. Another example is to figure out the probability that a couple has 3 children and all of them are boys. You would just multiply the probability of having one boy, which is 1 out of 2, times the second boy 1/2, the third boy 1/2, multiply all those together, and the probability of having 3 children that are all boys is 0.0125. So the multiplication rule comes into play when you see the word "and." Now notice these are for independent events. But not all events are independent. In that case, you're going to have to use rule number 8, the multiplication rule. If you want to use the probability of E1 and E2, you find the probability of E1 and multiply it by the probability of E2, given that E1 has already occurred. Well, looking and hearing this formula is kind of confusing, so let's look at an example that I know will be a lot easier for you. What's the probability of drawing 2 cards, 1 being a spade and 2 being a heart? Well, out of a deck of 52 cards, 13 are spades. If we draw 1 card out, then there's not 52 cards anymore. It affects the probability, so drawing a heart is now 13 out of 51. We multiply those together and we get the answer 0.0637. So the second part, you're figuring out the probability of drawing a card that's a heart, given that you've already drawn out 1 card and it was a spade. So those are the 10 different rules of probability, and let me give you a hint on this. So when you are working with problems, you'll have a little bit of guidance as to how to start them. When you're working a problem and you see the word "or," that's a hint to you that you're going to use one of the addition probability rules. So we've narrowed it down from the 10 to 2 rules. Then you just have to ask yourself, are these 2 events mutually exclusive? And that'll direct you to the correct rule to use. Also, if you have the word "and" in your probability problem, that tells us we need to multiply. So we've also narrowed those 10 rules down to one of the 2 that we need to use. Then you just need to ask yourselves, are these 2 events independent? As soon as you know that, you're able to use the correct rule. And then we know that given that is the conditional rule, and depending on if it's independent or dependent, we'll know which rule to use.